Good morning, everyone. Welcome back to the third day of this FDP. Today, the 12th of January, we will have sessions by Dr. Praveen Kumar Mishra, sir. He has been with us for the past 2 days, but today we have a full day session by sir. So I have already briefed you about Sir. Sir is assistant professor at Department of Computer Science, Department of Mathematics and Statistics at Dr. Shakuntala Mishra National Rehabilitation University. He has more than 16 years of teaching experience with many reputed papers, research papers in reputed journals, Scopus indexed, SCI indexed journals. He has one patent on machine learning on his name, and one PhD has been awarded under him. And we welcome you, sir, on behalf of the entire Amity fraternity. You are welcome once again to this third day of the FDP on data science with statistical methods using R programming basic course. So over to you, sir.
Very good morning to all of you. I hope I am audible and as well as visible to all of you.
Yes, sir.
Okay. Thank you so much, Dr. Anuradha, for giving introduction. And without taking too much of time, I think I should start the proceeding of the day immediately. So just give me 1 or 2 minutes so that I can check my slides are working or not. And after that, I will start my lecture immediately. Just a second. Excuse me. Let me put my presentation in slideshow mode. Excuse me. I think it is visible to all of you. And one more thing, I should check whether it is moving. It is moving. Introduction page is visible to all of you.
Yes, sir, it is visible, sir.
Ma'am, your voice is not coming. Hello.
Yes, I had muted myself.
Okay. So I think I should start. So till yesterday we have discussed a classification technique that was decision tree. Some more topics were left in that topic that I will discuss in the next lecture when I will discuss that association rule mining. Uh, right now, I am starting another topic, and it is also a topic which is treated as unsupervised learning. So classification and cluster analysis, as we know, the important techniques that partition objects that have many attributes into meaningful disjoint subgroups so that objects in each group are more similar to each other in the values of their attributes that they are to objects in other groups. Now there is a major difference between cluster analysis and classification. In supervised classification, the classes are predefined. The user already knows what classes there are, and some training data that is already labeled by their class membership is available to train or to build a model. The classification problem then is to build a model that would be able to label or classify newly encountered data. In cluster analysis, one doesn't know what classes or clusters exist, and the problem to be solved, excuse me, is to group the given data into meaningful clusters. Cluster analysis is the task of grouping a set of objects in such a way that objects in the same group are more similar based on some measure. Those measures we will discuss further in the lecture to each other, that to those in other groups no pre-classified training data is assumed to be available. The aim of cluster analysis is often exploratory to find if data naturally falls into meaningful groups with small within group variations and large between group variation. This is very important. Uh, sorry. Classification uh, within group variation and with a small within group variation and large between the group variation. Often we may not have a hypothesis that we are trying to test. The aim is to find any interesting grouping of the data. If possible, to define cluster analysis as an optimization problem in which a given function consisting of intra-cluster similarity and inter-cluster dissimilarity, which is given function consisting of intra-cluster similarity and inter-cluster, it is same as we marked here. So we assume that each object belong to only one cluster and overlapping of cluster is not allowed. Now, desired features of cluster analysis, what features are desired, what is required, or what should be the characteristics of clusters. Given that there are a large number of cluster analysis methods, the list of desired features that an ideal cluster analysis method should have the following. First is scalability, means if there is large data, extreme values are there. So scalability is possible. You can scale and lower down the digits. Then only one scan of the data set. Excuse me. Ability to stop and resume. Then minimal input parameters. Robustness, ability to discover different cluster shapes, different data types, means you can handle different data types, result independent of data input order. Now, this is all what we can explore in cluster analysis. So cluster analysis, it is divided into 1, 2, 3, 4, 5, 6 parts. First is density based clustering, then partitional clustering, then grid based clustering, hierarchical clustering, and model based. Now, the partitional clustering is again, it can be calculated or it can be done with k-means method. It is very important since it is an introductory lecture for this. So we will discuss this method, k-means method, to solve the problem, small problem manually, as well as we'll discuss through R programming. Then there is another method, expectation maximization method. Then grid based methods are there. Then hierarchical method, it is done with agglomerative method and divisive method. So these are the methods and these are the types of cluster analysis methods. Now, given a set of objects place them in groups such that the objects in a group are similar or related to one another and different from the objects in other groups. Like here you see there are objects in three colors. First is blue, then it is something brownish, and it is Mirawala pink. So you see, we can, without any calculation, or we can say that these are three different classes or three different clusters. So here you see intra-cluster distance are minimized. Means intra-cluster distance means within this group, the distances should be minimum as possible. And intercluster means this distance. Intercluster means this distance, this from here to here. Intercluster distances are maximized. Applications now, what are the applications? Industry understanding group related documents for browsing group genes and proteins that have similar functionality, or group stocks with similar price fluctuation. Then summarization, reducing the size of large data sets. So these are the now notion of cluster can be ambiguous. How many clusters can we divide like this? So we can have 2 clusters, we can have 6 clusters, 4 clusters. So types of clustering. A clustering is a set of clusters. These we have already discussed. Important distinction between hierarchical and partitional sets of clusters. Partitional clustering, a division of data objects into non-overlapping subsets. A sets of nested clusters organized as a hierarchical tree. So these are two methods. Now partitional clusters. So these are the original points. Now we can have 2 clusters for this one cluster, and we can treat this as one cluster and this whole as one cluster. Now there is another approach which is known as hierarchical clustering, and in this a dendrogram technique is used, in which you see dendrogram is constructed. So P1 is like this, then again P2 is this, and P4 is this. So here you can see P1 is this whole cluster, then P4 is contained here, then P3 and P2 is contained inside. Non-traditional hierarchical clustering. So non-traditional, here you can see this type of diagram, dendrogram P1, P2 and P3, P4, and both they all are contained in this type of. Other distinctions between sets of clusters: exclusives versus non-exclusive. Fuzzy clustering is one more type. Types of clusters, they are well separated clusters, prototype based clusters, contiguity based clusters, density based clusters described by an objective function. Now well separated clusters are quite distanced apart from each other. 3 well-separated clusters. A cluster is a set point such that any point in a cluster is closer or similar to every point in cluster that to any point not in the cluster. Prototype based. A cluster is a set of objects such that an object in a cluster is closer or more similar to the prototype or center of a cluster then to center of any other cluster. The center of a cluster is often known as centroid. This is very important. We do all the calculations on the basis of this centroid, the average of all points in the cluster or midwide, the most representative point of a cluster. Then contiguous clusters, nearest neighbor or transitive. A cluster is a set of points such that a point in a cluster is closer, more similar. That is same definition is. Then density base, a cluster in a dense region of points which is separated by low density regions from other regions of high density. Used when clusters are irregular or intertwined and when noise and outliers are present. So this method is used. Then clusters defined by an objective function finds clusters that minimize or maximize an objective function. Enumerate all possible ways of dividing the points into clusters and evaluate the goodness of each potential set of clusters by using given objective functions. Can have global or local objectives. Hierarchical clustering algorithms typically have local objectives. Partitional algorithms typically have global objectives. A variation of global objective function approach is to fit the data to a parameterized model, parametric model. Parameters for the model are determined from the data. Mixtures model assume that data is a mixture of number of statistical distributions. Then characteristics of the input data are important. Type of proximity or density measure, central to clustering, then depends on data and application. Data characteristics that affect proximity and or density are dimensionality, attribute type, spatial relationship in the data, then distribution of the data, then noise and outliers, clusters of differing size, densities, and shapes. Now, sorry, clustering algorithms, k-means and its variants means k-means and other improved versions of k-means. Then there is hierarchical clustering. Then density-based clustering is also there. Now, first of all, we are going to discuss this k-means clustering. So, as we already discussed, partitional clustering approach, this is a partitional clustering approach. Now, as name suggests, k-means. So this k is very, very important in this method. This k is very important. Number of clusters means in how many clusters you want to divide the given data set. Each cluster is associated with a centroid. As I have already told you that this centroid is the representative of that data set, data point. Each point is assigned to the cluster with the closest centroid. The basic algorithm is it's a very simple algorithm. Select k points as the initial centroids. Means suppose it is asked that divide it into two clusters. So the value of k will be 2. It will be treated as k1 and we will assign the data points as per the calculation into k1 and k2. Right? Then repeat, select the k points initial centroids. Then after calculation, centroids will shift and we repeat the process from k clusters by assigning all points to the closest centroid. Recompute the centroid for each cluster until the centroid don't change. So suppose if we plot a scatter diagram of the given data set, and it is like this. Initial uh, scatter diagram in iteration 1 means initial data points are like this. When we calculate the centroids and the values are shifted after first iteration, there is some change. You can see there is some change. Initially, these brown points are there, little smaller in number. Then these blue points are there, green. These circles are there. These rectangles are there. So initially 1, 2, 3, 4, and 5. Five type of data sets, data points are there. Now in next iteration, when we do the calculation, you can observe that number of these red points are increased. Means allocation of data points is in process with the help of centroid calculation and distance calculation. When we perform one more time, you can see there is more increase in this type of points, and there is a decrease in this term, means these are allocated to this cluster. Now in iteration 4, you can see all this type of heart-shaped points are converted into these red points. They are still here and they are still here. Now you can see this point is also converted into uh, this shape. This was earlier green in yes, this was, and now it is. So on recomputation of distance and centroid, we are allocating. So finally you see here the in the final iteration, you see all the diagrams here one by one. Initially, there was a group, this red one, then this green one, then this blue, and this green. So five groups were there in initial scatter plot, and the final is after iteration 6. You can see here after grouping, you have this group, you have this group, and you have this group. So finally, we have three groups, or we can say three clusters after performing k-means clustering. Now, simple iterative algorithm, it is simple. Choose initial centroids, repeat, assign each point to nearest centroid, recompute the cluster centroids until centroids stop changing. Initial centroids are often chosen randomly. Sometimes we calculate the distance, maximum distance with inspection only, and then we take initial clusters. The centroid is typically the mean of the points in the cluster. That means suppose there are 2 points 2 comma 3 and 5 comma 8. So we treat this point as x1 and we treat this point as, this point as y1, and this is x2 and this is y2. So centroid C1 will be x1 plus x2 divided by 2 and comma y1 plus y2 divided by 2. So it will be 2 plus 5 divided by 2 and 3 plus 8 divided by 2. So it will be 7 by 2 comma 11 by 2, or we can say 3.5 comma 5.5 will be the centroid, right? So it is very simple, nothing to worry. And similarly, we can calculate the distance of 2-point distance between 2 points. The centroid is typically the mean of the points in the cluster, but other definitions are possible. K-means uh, will coverage for common proximity measures with appropriately defined centroid. Most of the convergence happen in first few iterations. Complexity is of order this, so these are the mathematical things. Then K means objective function. A common objective function used with Euclidean distance measure is sum of squared error SSE. It is a statistical term, sum of square of error. For each point, the error in is the distance to the nearest cluster center. To get SSE, sum of squares due to error, we can calculate with this formula. We are not going to use this. X is a data point in cluster Ci and Mi is the centroid for cluster Ci. Then SSE improves in each iteration of k-means until it reaches a local or global minima. Now, importance of choosing initial centroid. Depending on the choice of initial centroids, B and C may get merged or remain separate. So this problems with selecting initial points. If there are k real clusters, then the chance of selecting one centroid from each cluster is small. Chance is relatively small when k is large. If clusters are same size n, then for k is equal to 10, then probability will be factorial 10 divided by 10 raised power 10. It will be. So these are mathematical things. We are not going to. Now we'll discuss straightforward uh, the k-means method. The method is called k-means since each The method is called k-means since each of the k clusters is represented by the mean of the objects. That is called centroid. It is also called the centroid method since at each step the centroid point of each cluster is assumed to be known, and each of the remaining points are allocated to the cluster whose centroid is closest to it. Once this allocation is completed, centroids of the clusters are recomputed using simple means, and the process of allocating points to each cluster is repeated until there is no change in the clusters. So this is the method we will follow. The k-means method uses the the k-means method uses the Euclidean distance measure, which appears to work well with compact clusters. If instead of Euclidean distance, the Manhattan distance is used, the method is called k-median method. So if in place of Euclidean distance we use Manhattan distance, the k-median method is it will be known as k-median method, and k-median method can be less sensitive to outliers. So that is why we always use k-mean method. Now, what is this k-mean method? Suppose this is a point P. So this point P will have two coordinates. One is this vertical distance y and this horizontal distance x. So this point P will have some coordinates, for example, say X and Y. Then there is another point Q here. It will also have some coordinates. Suppose this is X1, Y1 and this is X2, Y2. So this now this distance is R. This is equal to this. This will be Q1 minus P1. This is P1. This will be Q2 minus P2, this distance. So distance P comma Q means this distance. This distance dpq comma P, the Euclidean distance of the points P1, P2. Suppose the coordinates of this are P1, P2 and the coordinates of this point is Q1, Q2. So distance, Euclidean distance between points P1, P2 and Q1, Q2 is given by this dpq is equal to Q1 minus P1 whole square and Q2 minus P2 whole square. The Manhattan distance, how you will calculate the Manhattan distance between 2 points? It will be mod of Q1 minus P1 plus mod of Q2 minus P2. So this is how we can calculate the Manhattan distance. These two types of distances are used for calculating the distance between two data points or the distance between two centroids. Now the k-mean algorithm, this we have already discussed, but we are repeating it. Select the number of clusters. Let there be k. Suppose k is equal to 2. So you have to divide the whole data set into 2 clusters. If it is k is equal to 3, then you have to divide the whole data set into 3 clusters. Take k seeds as centroids of the clusters. Then compute the Euclidean distance of each object in the data set from each of the centroids. Then allocate each object to the cluster it is nearest to based on the distances computed in the previous step. Then compute the centroids of the clusters by computing the means of the attribute values of the objects of the clusters. Check if the stopping criteria has been met, means all the data points are allocated in cluster 1 or cluster 2 or cluster 3. That will be the stopping criteria. One may decide to stop at this stage or to split a cluster or combine two clusters until a stopping criteria is met. Now, we'll take the example straightforward. We'll take the example k-means method. This is the example. Suppose that we have the following data. There are A, B, C, D, E, F up to J. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. 10 points are there denoted by A to J and their coordinates are like this. Identify the cluster by applying the k-means algorithm with k equal to 2. So it is already given here what is the value of k. That means into how many clusters you have to divide the all data points. Means you have to divide these all points into two groups, two clusters. Try using initial cluster centers as far apart as possible. So it is already said that the you can take the values of initial clusters as far as apart. So this is the criteria. Now the scatter plot of these points, scatter plot of these points is like this. The value, you can see the value of A. The value of A is here 2, 0. So when you plot, the value of A is 2 at x-axis and y-axis is 0. 2 comma 0, right? Value of b is 1 comma 2. The value of b is 1 comma 2. This is 1 and 2. Similarly, we have plotted all the values. So now from here, you can see that this A point is the lowest coordinate, right? And from this A point, the distance of B, this, this. So from this A point, oh, my slide is visible to all of you?
No, sir.
Okay, okay. I think it is share is stopped. So let me share again. Just a second. Just a second. Is it visible right now?
Yes, sir. It is visible, but it's not in slide mode.
Okay. Now,
Not yet, sir.
okay.
So you can put it in slideshow mode and then share your screen.
Oh, that is I'm trying, but it's not working right now. Just a second. Now it is in slideshow mode.
Yes, sir.
Okay. And it is moving also, I think. So here you can see this point 2 comma 0, this point 2 comma 0, and the criteria was the points, clusters points as far as apart. So you see this J point and this I point, these 2 points are maximum distance apart from this A point, right? If as per your view, if any other point you think that is more distant from A, so you can suggest. But I think these 2 points are at maximum distance from point A. So we take these 2 points. First, we calculate the distance between A and I. These 2 points, uh, let me. So these 2 points, you see here, this point A is 2 comma 0 here. This point I is 4 comma 4 and the another point J is 3,5. So I am confused that whether the distance between A comma I is maximum or the distance between which distance is greater. So we check which distance is greater. So we'll calculate the Euclidean distance between these 2 points. So the points were as the points were 2, 0. This was A point, and the point I is 4, 4, right? 4, 4. So suppose this point is x1, y1 and this point is x2, y2, right? So x2 minus x1, this is x2 minus x1 whole square plus y2 minus y1 whole square. This is the simple distance formula which you have studied in class 10th, right? So this comes 4.47, right? Then we calculate the distance between A and J. That comes 5.10. So you can very easily conclude that the distance between A and I is 4.47 and distance between A and J is 5.10. So this is the maximum distance. So what we take, let us consider two clusters K1 and K2 such that the centroids of these clusters are A 2, 0 and J, because the distance between these two, when we compare, the distance is maximum for A and J. So we take A and J respectively as K1 and K2. So K1 will be A 2, 0 and K2 will be J 2, 3, 5. So this will be K2. Now, now we divide these values in two parts, means A is here and J is already here, right? Now we calculate the distances between these centroids and allocate the points in this cluster and this cluster after doing the calculations. So C1 is the centroid of this is 2, 0 and centroid of K2 is 3, 5 right now. Initially, these are the initial centroids. Now the distance between Euclidean distance is given by the formula XO. XO means observed value, and XC is the current centroid. Then YO minus YC whole square. Now the point B. Now we have to calculate this. Now, sorry. Now you see this point A is the centroid of cluster 1 right now, and this point J is the centroid of cluster 2 right now. Now there are two clusters. Suppose there are two parties going for the election, right? In the current scenario, you can understand. So this is the centroid of first party and this is the centroid of second party. And now this person B wants to go in one of these parties, one of these two clusters. So now we have to allocate this B, point B, having the coordinates 1, 2 in one of these two clusters. So we calculate the distance of this person from this party, and we calculate the distance of this person from this party or this clusters. And whichever the distance is less, he will select that party or that cluster, in very simple words, right? So this is the Euclidean distance formula. Now the Euclidean distance of point B 1, 2 for clusters K1 and K2. So we calculate the distance of 1, 2 with 2, 0 and 1, 2 with 3, 5. You see here the distance between B and C1. B and C1 means this coordinates is 1 minus 2 whole square, because this is 1 and first coordinate is 2. 1 minus 2 whole square and 2 minus 0 whole square, it is 2.24. And now we calculate the DBC2. DBC2 is 3.61. So you can see this distance is minimum, means the distance from B to C1. C1 means first cluster, K1. So this point B will go here. A is already here. Point A is already here, and B will also come here. So there will be 2 points in this cluster now after this classification. So since minimum distance BCI, I going from 1 to 2 is DBC1, that is 2.24. So the point B 1, 2 goes to cluster 1. It will go to cluster 1. So the cluster K1 will be now 2, 0. It will have two members now. This party will have two members. And cluster K2 is having one member only, that is J 3, 5. But now the centroid, initially the centroid of this cluster was 2, 0. But now there are two members. So the centroid of this cluster will change. Like initially there was only one member in this party, so all the rules were according to him, point A. But now there are two members in this party, so center of power or power center or centroid will change now. How it will change? It will be it will be 2 plus 1 divided by 2. This value plus this value, and 0 plus 2 divided by 2. 0 plus 2 divided by 2. So new centroid will be 2 plus 1, that is 3 by 2, 1.5, and 0 plus 2 divided by 2, that is 1. So new centroid will be you can see here the centroid of K1 is 1.5 this, and the second coordinate is 1. So new centroid will be K1 will be 1.5 comma 1 and C2 will be 3 comma 5, right? C2 as it is because nobody is joining that party. So there is only one person. So rules are as it is according to him right now. We move further. Now there is point C who wants to join one party out of these two, means K1 or K2, right? So we will calculate the Euclidean distance of this point C with this C1, which is changed, new centroid, and with this C2, which is older one, right? So again, we will calculate the distance of C with C1, 2 minus 1.5, 2 minus 1.5, and 2 minus 1. So it comes 1.12. I think you can do this simple calculation. There is nothing very difficult. Again, we will calculate the distance from C to C2. It will be 2 minus 3 whole square, 2 minus 5. So it comes 3.16. So distance of C from C1 is only 1.12. It is only 1.12, right? And distance of C from C2 means the distance from second cluster is 3.16. So which one is minimum? This is minimum. So again, this C point will also go to this party, this C2 comma 2. So now this party or this cluster will have three data points, and this is having only one, that is J. Now again, since initially there was only one person, that is A, so all rules were as per his convenience. But when this second point B has joined the party, rules were changed. There was new centroid 1.5, 1. Now one more person has joined the party, so new centroid will be calculated. How it will be calculated? It will be 1.5 plus 2, because this coordinate is 2, 2, divided by 2, then 1 plus 2 divided by 2. So this centroid will change again, right? Sorry, excuse me. Now since minimum distance of D to DCI, DC1, DC1 is 1.12 and DC2, 2, so this point C will go to this cluster again. So cluster K1 will have now 3 points, A, B, and C, and cluster 2 will have only 1 point, one person or one member in the party, that is point J. Now you see here the centroid of K1 is changed. How it is changed? 1.5. Excuse me. I think I can take a glass of water, then I will continue. So you can see here we have classified these 2 points after taking initial points, initial seeds as A and J in two clusters K1 and K2. Now we have in cluster K1 there are three members, and in cluster K2 there is only one member. Again, the centroids are calculated here. You can see it is C1 1.75 and 1.5, and C2 is as it is. C1 is calculated like this: 1.5 plus 2 divided by 2. So it will come 1.75, and 1 plus 2, that will be 3 divided by 2. So it will be 1.5. So this will be new centroid for new power center for this party, and the power center of this party is as it is, because this is one member party, right? One man show is here. So centroid is as it is here. And in this party now there are three members. So they have to make compromises. They have to take care the feelings of all the persons. So the new centroid is like this, right? So new centroid K1C1 is like this. It is calculated here. Now you have to allocate the point D into these two clusters. So we will calculate again the distance from C1. It comes 1.35, and we have calculated the distance from C2. So again you can see the distance from C1 is 1.35, and from C2 it is 3.0. So this member or this point will also go in cluster K1, right? So since minimum distance DCI is equal to DC1 1.35, so D point goes to cluster K1. So cluster K1 is 2.0, 1 comma 2, C 2 comma 2, D is 3 comma 2, and the point D is also here. You can see the point D is also here. There are four members, and K2 is still all alone. He is one man party. Now the power center or centroid of this cluster will again change. New centroid will be the mean of old centroid plus the coordinate of new one. So this you can see, initially the centroid was 1.75 comma 1.5. Now 1.75 plus 3, because the new point is 3 comma 2. So plus 3 divided by 2, 1.5 divided. So it is like this. So 2.375, 1.75 is are the new coordinates, and C2 is as it is. So the
excuse me, there is one query from one participant. Should I ask?
yes, ma'am.
He is K means clustering के लिए है. Is it only calculated for 2 dimensions, that is X and Y? How we
No.
calculate?
It can be calculated for 3 dimensions also.
So how do we do it for 3 dimensions? Like if you are having X, Y, and Z simultaneously.
Let me explain. Let me explain. Suppose the coordinates are x1, x2, x3, right? And y1, y2, y3, right? So centroid will be x1 plus x2 plus x3 divided by 3. It's as simple as that. Y1 plus y2 plus y3 divided by 3. So centroid will be calculated accordingly. No issue. I think it is clear now.
Yes, it was from Anju Khandelwal, madam.
Okay,
You
okay.
are able to hear, ma'am. I hope you are clear now.
So now the Euclidean distance E2 comma 3, it will be calculated for point E. We have to classify this point also. So the distance between E and C1 means new centroid is 1.31 and the distance between E and C2 is 2.24. So this party K1 is very powerful. It is attracting each and everyone, and the distance is always coming lesser in this case. So again, point E will also go to this cluster K1, right? So you see, since minimum distance D of Ci will be D of C1, it is 1.12. So point E will also go to cluster K1. So now this is a very big party having 5 members A, B, C, D, E, and K2 is again one man show. Now Centroid will again change. I am not going to explain this. I have calculated for 4 points. So I think all of you are now able to calculate this yourself. So new centroid will be like this 2.1875 and 2.375, and we will calculate the distances. Now we have to classify this F point 3,3 for clusters K1 and K2 are given by this. Distance of F of C1 is 1.03 and distance of F of C2 is again 2.0. So this F point will also go to cluster K1. Now this K1 cluster have these points and K2 is still alone. New centroid is calculated here. You see, new centroid is calculated here. New centroid will be 2.1875 plus 3 divided by 2 and 2.375 plus 3 divided by 2. So the point G, for point G, distance is from C1, distance is 1.44, and now for G from C2 it is only there is a slight change. Now it is 1.41. So this point G will go to cluster K2. This point G goes to cluster K2 and new centroid will be calculated. And new centroid will be calculated and now H point is left. So distance from H is calculated. It is coming 1.37 and distance from H to C2 is calculated. It is again in this case 0.71. So this point H will also go into cluster K2. So finally, you have these two clusters for this example, 2 comma 0, B point is 1 comma 2, C is in 2 comma 2, D. So K1 cluster having 1, 2, 3, 4, 5, 6 points and K2 having 3 points. So this is the final result for this. No, it is not final. I think 1 point is still left. So sorry, I point is still there. So for this, distances are also calculated. And in this case also 1.27 is less than 1.92. So this point I will also go to cluster K2. So 6 point, it is correct because there were 10 points. So K1 cluster will have A, B, C, D, E, F points, and K2 cluster will have G, H, I, and J points.
Sir, there is another doubt.
Yes,
Which
ma'am.
distance measure is efficient? If we apply different distance measures for the same data set, then is it same result?
No, actually it depends on the nature of the data set. If the data set have more outlier types of data, then k-means method is better. And if there are no extreme values in the data set, like a very high value and a very, very low value, so in that case, the k-means method is better. And if the data set don't have many extreme values, in that case, k-median method, or that is Manhattan distance, is useful. And normally means it is in flow that normally we use Euclidean distance. Manhattan distance is very rarely used.
Okay, Gomti ma'am, I hope your query has been solved.
So I am going to give you one uh, question to solve with this method. If you are willing to try this. Just a second. Is it visible to all of you?
Yes, sir.
Is it visible to all of you? Yes. So,
Yes, sir. Yes, sir.
okay. Just wait, just wait, just wait. So this question number 2 is visible to all of you.
Yes, sir.
Suppose that the data mining task is to cluster the following 8 points. So there are 8 points: A1, A2, A3, A4, A5, A6, A7, and 8, A8, right? And coordinates are 4,6, 2,5, 9,3, 6, 9, and 7, 5, 5, 7, 2, 2, 6, 6, right? Everyone can see this.
Yes, sir.
So can you solve this? Can you solve this? And in the question, suppose initially we assign A1, A2, A3 as the seeds of 3 clusters. That means the example which we have discussed, in that I have taken k equal to 2. But here the initial seeds are A1, that means the first point, A2 and A3 are the, that means you have to divide this data into three clusters. I will share this solved examples. 3, 4, 5 examples are manually solved with me. So I will share with this document with all of you. Hello, you can hear me?
Yes, sir.
Yes, sir.
Okay, okay, okay.
Yes, sir.
Actually, I have given you the assignment. That is why I have muted myself. So you people are writing that there is no audio. So somebody is writing, I thought I have network problem and etc. So there is no network problem. There is nothing like that. I have taken a small break after giving you a assignment. So here in this problem, you can see that you have to divide the data set into three clusters. Initially, we have taken three clusters K1, K2, K3. The coordinates are like this. Coordinates are like this, and so this is the K1 4,6, K2 is 2,5, K3 is this. So we use this XO minus XC whole square, YO minus YC whole square, and we have calculated the distances. First, since A1, A2, and A3 are seed points, so we have to allocate A4 in any of these three clusters. So you see the distance of A4, this point A4, 6,9 is calculated from these three clusters or centroids. Initially, these are the centroids, initial centroids. So it is calculated 3.61, 5.66, and 6.71. So the minimum distance is 3.61. So this A4 will go to cluster K1, right? So you see this point A4 will go. So the data point A4 enters into cluster K1 and the centroid of this cluster will change. It will come 5, 7.5. So you see K1 is having 2 points A1 and A4 and K2 is having only 1. K3 is still having 1. Centroid of this point is changed. Again, we have to classify after A4, we have to classify A5. So distance of A5 is calculated from centroid of K1, K2 and K3. So here you see the minimum distance is 2.83. So this point will enter into cluster A3. So here you see K1 having 1 point, K2 having K1 having 2 points, K2 having only 1 and K3 having 2 points. Now centroid of K1 will remain as in second iteration. K2 will remain as it is as first iteration and K3 will change. K3, the centroid of K3 will change. It will be 9 plus 7, 16 by 2. It is coming 8 and 3 plus 5, that is 8 by 2. It is coming 4. So new centroid is 8, 4. Now you have to after A5 you have to classify A6. Distances are calculated here and the minimum distance is 0.5. So this A6 will enter into cluster K1. So now you have here, you can see the result. K1 having 3 points, K2 having only 1 and K3 having 2 points. Now the centroid of K1 will again change, right? And distances are calculated here. You see distances are calculated here. 6.05 3 and 6.32. So this is the minimum distance 3. This is the minimum distance. So this A7 will enter into cluster 2. So here you see 3 points right now. 3 points are in K1, 2 points in K2 and 2 points in K3. Now the first time the centroid of K2 will change, right? It will be calculated accordingly. 2 plus 2 divided by 2. I think it is something else. Then distances will be calculated as per the new centroid, and minimum distance you can see it's 1.60. So the last point A8 will enter in K1. So these are the final groups or clusters where K1 cluster 1 having 4 points, K2 having 2 points, K3 having 2 points, and there were 8 points which we have to classify in 3 clusters. Now you see there is another example we have. Consider the data about students given the following table. In the following table, the only attribute are age and 3 marks. So there is an attribute age and marks 1, marks 2, marks 3. Use k-means algorithm to make 3 clusters of the students. So you see here we have to make 3 clusters. So initially we have taken S1, S2 and S3, means student 1, student 2, student 3 as seed clusters. So their coordinates are here. You can see the coordinates of the student 1 will be 18, 73, 75, 57 or 51, whatever it is. 57, and the coordinates of second are these. K3 is these. So you have to calculate the Euclidean distance. Suppose you have to classify student 4. So you have to calculate the distance of student 4 from all these 3 points, and you see the distance. You see the distance 27.06 for this K1, 43.36 for K2 and 21.63. So this is the minimum distance. So student 4 will be classified in cluster 3. So accordingly, we can calculate the distances and allocate all the students in different clusters, and this will be the final result, final clustering result. This will be the final clustering result. You see K1 having student 1 and 9, K2 having student 2, 5, 6 and 10, K3 having student 3, 4, 7 and 8. I will share this document with all of you so that if you are willing to solve, you can solve. Now again, I will come to my slide. So Then after this, hierarchical clustering produces a set of nested clusters organized as hierarchical tree, and it can be visualized as dendrogram like this. It is a tree-like diagram that records the sequences. Strength of hierarchical clustering: do not have to assume any particular number of clusters. Like in k-means clustering, any desired number of clusters can be obtained by cutting the dendrogram at proper level. They may correspond to meaningful taxonomies, example in biological sciences, animal kingdom, and so on. Hierarchical clustering, two main types of
Sir,
hierarchical clusterings are,
excuse me, sir.
yeah,
Before you proceed, there is one question. How are the students clustered according to age or marks?
they are according to marks.
Okay. Okay, then there is another question in the chat box. Is it possible that let the computer decide the number of clusters, its final centroid and coordinates of elements? Sir, means this is a very means why will computer decide that how many clusters you want? You will have to give the number of clusters. Okay, because it is your numerical, so you will have to specify in what way, in how many clusters you have to means partition your data.
No, no,
Computer,
no. If you can give the system
yes,
intelligence as you have, means programmed the system artificially, and the system has the intelligence or thinking power as you have, then you can generate an algorithm and you can do that. No
and
issue.
moreover, there is another option that you create a program in which you are asking the number of clusters from the user.
Yes,
Computer
yes,
will not decide. You ask
yes.
the number of clusters from the user, that how many centers, how many clusters you want. These are two ways. You make the computer intelligent, or you take number of clusters during the program. You don't predefine. You take it from the user during the runtime. There are two
Okay.
options. Then it is very much possible that you take the number of clusters from the user during the runtime.
Okay, it means initially I have to decide the number of clusters.
Yes,
Yes.
initially you have to decide. Yes,
Okay, can I proceed?
yes, sir. Yes, sir.
Okay, so two main types of hierarchical clustering: agglomerative and divisive. So in agglomerative, start with the points as individual clusters. At each stage, merge the closest pairs of clusters until only one cluster left. And in divisive, start with one all-inclusive clusters. At each step, split a cluster until each cluster contains an individual point, or there are k clusters. Then in traditional hierarchical algorithm use a similarity or distance matrix, merge or split one cluster at a time. Agglomerative clustering algorithm, basic algorithm: compute the proximity matrix, let each data point to be a cluster, repeat, merge. So this is the algorithm when we implement it. So start with clusters, individual points, and a proximity matrix. This is proximity matrix P1, P2, P3, P4, P5, and like this, these type of figures. What's the time actually? It's uh, I think I should discuss the R program with you for K means, so that you can have an idea, complete idea about k-means clustering, because it is not possible to cover all the methods in 1.5 hour or 2 hour lecture. So I think I have explained the k-means clustering properly. And if you have the idea about how to implement in R, then it will be very useful for you. So let me. Anuradha ma'am, are you there?
Yes, sir, very much there.
I think in my laptop R is not installed. It is after that refurbishment, and it will take time. I have shared a document with you with R codes. So can you execute
Yes,
and
I have
show
seen.
the audience how to implement? That will help me, because if I will install it right now, then it will take at least 10-15 minutes time.
Yeah, okay. Sir, just give me 1 minute. Let me open the
I'm
document.
very sorry. After means I don't have right now R in my system.
Just give me 1 minute, sir. So, should I do it in R Studio?
Yes, yes, sir.
Okay. So this is a program for implementation of k-means algorithm. The data set which we have to take, I am entering in the chat box. You people can simultaneously type that data in your R prompt as well.
Yes, 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 ma'am. Please share with the audience so that they can simultaneously do that.
I have means now I'm entering the data in my R console. Is my R console visible?
Yes, it is visible to me. I think it will be visible to audience also.
This value I have entered of A, this value I am entering of B. So here you can see at this side the values of A, the values of B. These are being visible here in the environment section of the R console. The value of D I am entering now. Can be simultaneously done by everyone. Then the value of E. Then we are entering the value of F. The value of G. H. And then the value of I. Value of J. Okay, now we have to combine the data set. Now you can see here we have the complete data set from A to J. Okay, so if you see the chat box, I have entered you these values. So this one is
Madam, in the whatever data is entered into chat box, it is not being copied and pasted in the console. When
Can
we
you type it, please? You type it, sir.
type the data, whole data.
Yes, you type the data as I am doing.
Oh.
With R commands, you type the data, please. And from chat box, you can simply copy. See, I am just sharing my screen again.
No. From the copying, it is not taking. I mean, there is some.
See, is this visible? Is this visible to you? This window is visible. Which window is visible?
Whatever checkbox, whatever is in the checkbox.
Yes, chat box. You just select it, sir. From chat box, it is being copied easily.
But in my console there is some mistake or something like that. I mean the unexpected comma in A something like that. So
Okay, so you might be putting some extra comma, sir. You might be putting some extra comma.
in the chat box also it is in comma.
In my console also I am giving comma, but maybe before A or somewhere you are writing a extra comma. This is what I am saying. Right?
Data is separated by comma, okay?
Data is separated by comma, but in between A and C here, there is no comma here. There is no comma here.
Okay. Let me try.
Is the screen appearing bigger now? Is the screen size appearing bigger now?
Yes, ma'am, yes.
Okay, so I think it is very much clear, visible how it is being entered. Now, by using the rbind command, I am combining the data. Okay, so I have given the command m rbind a b c d e f g h I and j. Sorry, I have missed j. So I have combined the data. Okay, so here you can see the value of m is this. Now, after combining the data, we will have to apply the function k-means for clustering. So as sir has said that here you will have to use the command km and you will have to use the command km here, and then I have entered the value of m because in m I have stored the combined data. Then number of centers I have given as 3 and maximum iteration I have bounded as 40 because after 40 iterations I don't want any iteration. If it is coming in 3 clusters after 40, then it is fine, otherwise that would be my final result. Okay, so as soon as I enter, it will give me the list of elements. Okay, so this is km. It is giving me the list of elements. It has combined the data. It has clustered the data. So when I run the value of km, I will get these are the available clusters. Okay, so this is the clustering vector and these are the 3 clusters that I have got. Okay, so cluster number 1, cluster number 2, cluster number 3. Done? Yes, okay.
Ma'am, can you post this code in WhatsApp group or somewhere so that I can also get it?
Ma'am, please post all the codes which I have shared with you so that they can do themselves also.
Okay, so should I put the
Yes,
file in
ma'am.
the
Yes, ma'am.
Yes, yes, you can
Yes,
put
ma'am.
the
In the
file
WhatsApp group.
WhatsApp group.
Yeah, WhatsApp,
In the
ma'am, because
WhatsApp group, ma'am.
I'm not able
not
to
in
see
the
any chat
Teams?
on Team.
No, you want it in the chat
Yeah.
of Teams?
No, no, ma'am, WhatsApp,
No, no.
please.
In the on the
Teams
WhatsApp
chat
group.
is not visible.
Chat is not visible to you all. Okay, okay, okay. I'm just doing.
Put in the WhatsApp group, ma'am.
Yes, ma'am. Just doing. Give me 1 minute, ma'am.
It is just codes are means very well tried and tested. So
Sir, this is
just
having 5 to 6 practicals, the file which you have sent to me.
so put the k-means practicals in the chat box, and rest we will discuss in the next lecture.
So 3 practicals are there for k-means.
I think 4 are there for k-means and 3 are for in that file association rule mining.
Okay, okay.
So put 4 for this lecture. In between they will do, and next in the next lecture we will do the association rule mining practicals.
Okay, sir. Okay. So the last one is quite big. Should I put that one also?
Please put. They will do. They
Okay,
will
okay.
enjoy the programming.
Okay, sir. Okay, as you say.
I hope the participants have enjoyed the session doing the calculation, and they have learned how to do the clustering manually as well as they will do with the software, our software.
Yeah, it's there in the WhatsApp group now.
And I think we should conclude now. We'll take a break of half an hour and we'll start by it's 11:12. So we will start the next lecture by 11:40 or
Yeah.
11:45. If anybody has any query, they can ask in the next lecture also, because I am available for whole day today.
Yes.
Sir, could you please also share that PDF file where you had solved the mathematical issues?
Yes. I have already assured you that I will share all the material which I have discussed till now and which I will be discussing in the next and next to next lecture. Don't worry about that.
So share it in the
Sir,
WhatsApp group.
Don't worry, madam. It will
Madam,
be shared
please
in
give
the.
us some time. As soon as sir sends me, I will forward in the WhatsApp group. Please don't worry. Those who
Don't
have
worry.
done
Okay,
first FDP with me, they know that I will give everything.
okay, ma'am.
And I try to give it on the same day, ma'am. You know, I am
Yeah,
working.
I know. Yeah, I know.
Please give us some time, ma'am.
Okay.
good morning, sir. Sir, in this session, there is also provision to talk about factor analysis, sir.
What?
This is
Pardon?
today's what you learn. That is about cluster analysis. Is it any session is there for factor analysis?
In the last session.
Okay, it is in there, sir.
In the last session, it is multivariate analysis, principal component analysis, factor analysis, etc.
Sir, have you downloaded the file which I have shared in the WhatsApp group about the sessions today?
Today's session. No, I have not downloaded.
Yes, please download from the group. I have shared an Excel file which is having every list of means whatever we are doing for all the 5 days. Okay, so please
Okay.
download that and see that
Thank
we are proceeding according to our plan only. Though it is very much means at the time of planning, I did not think that we will go so deep in the sessions. So means I have put a lot of things. Shalabh sir was also saying the same thing कि अनुराधा तुमने बहुत ज़्यादा डाल दिया, and Praveen sir is also saying that you have put a lot of syllabus for 5 days. But means my motive was that after 10 days of training, because 5 days we have already done in June, and 5 days this. So I wanted that after 10 days of training, everyone should know everything about machine learning. But the speakers are having problem because I have put too much of content.
Actually,
But we
it will take a whole day to explain all
right,
three methods
right.
for clustering itself. So,
Sir is trying his best. Uh, to,
Madam, have you shared started
yes,
Salaf sir's lecture? Started
every,
evening. Started evening. Salaf sir's lecture.
sir, I
Perhaps
have
that.
shared everything in the WhatsApp group. Please see. Yesterday's everything was closed yesterday only.
Ma'am, I
Yes,
have
sir.
doubt, ma'am. Yes, ma'am. I entered the same data in my R console. I got different answer. Clustering vector, cluster means everything is different. My data. The same data I entered my console.
Okay.
I got 3 cluster of sizes 1, 5, 4, but you got 4, 2, 4. Is a unique answer?
Sir, unique answer is not guaranteed.
Okay. My clustering vector is also different. A is you got A is 3, B is 1, but I got A is 2, B is 3. It's different.
You have entered the
Same data, ma'am. Whatever you
same
post in the
data, sir.
sandbox.
Let me just see. Sir, will you share your screen?
Yeah,
Let's
just a
see.
minute. Is it visible, ma'am?
No, sir. Please zoom it. Not yet. Please zoom it. You can go to view and then plus sign is there. You press that, it will zoom the screen. Go to view menu. View file
Yes.
edit. View में you go to plus. No, it is not zooming. Yes, it is zooming. That you can have different values. There is no problem in that.
Okay, ma'am.
You can have different values. Means this is showing iterations, na? So maybe your screen is showing some other iteration. Okay.
Okay, ma'am. Okay, ma'am.
Because if you do manually, you will get these data points. You will get these points if you do manually, because we are giving 40 iterations. So after every iteration, a different set of value is shown.
Okay. Okay,
Yes, sir.
ma'am. Yeah, thank you.
Okay. So that's all for today. Means for this session. Thank you so much, sir, for joining us. Sir has already left, I think. So we'll resume by 11:40. Thank you so much, everyone, for joining. I am just stopping the recording of